Education isn't what it used to be. Just ask these inventors of the future.
This is a really cool event because we're teaching kids about science.
I get elbow deep in a teaching tool like no other.
You've got a coastal town with an bay, and then the ocean out there, and I just accidentally created a lake.
Math whizzes get serious about a national competition.
It gives them like a different perspective of mathematics.
And tech helps students create pieces of history.
What 3D printing really allows us to do is to bring potentially these historical artifacts into your own home.
Education is getting smarter. I'm Chuck Pell. I'm an artist, entrepreneur, and futurist. And we'll see how tech and teaching are coming together in this edition of Earth 2050. Welcome to Earth 2050. Today, we're taking a look at how future tech affects something close to all of you, education. As we approach the year 2050, curious students don't have to wait. The future is coming to you. That's just what happened as thousands of kids, parents, and teachers gathered for this Young Innovators Fair, held just outside of Philadelphia. Robots, computers, and all sorts of gadgets were there for these future futurists to get their hands on and try for themselves.
You just see all this cool, fun stuff, and it just makes you think, I want to do this when I'm older. I want to do this. So it inspires you to do all kinds of cool science things and be a great engineer.
Scientists, engineers, and robot makers attended the fair. Their aim? To answer questions from kids who may be considering careers in science and technology, to let them know about jobs that take brains and are anything but boring.
But this is an educational event, but it's an educational event that kids don't realize that they're learning. It's fun. And I think that's what's different about when you go to school, when you're in a classroom, that here, it's not that you're sitting at a desk and learning, this is fun learning.
Some of these kids are in high school. Others are barely out of kindergarten. But curiosity knows no boundaries. Young and old alike agree. It's never too early to get started on a possible career.
My sir said education matters because it is extremely important. And we want to have fun with experiments, and we just want everybody to have fun while they're learning.
This is part of a nationwide effort to push STEM, science, technology, engineering, and math for this generation of school students. Event producer Gabe Young, who used a bit of low-tech to cover as much ground as possible, says kids can learn as much outside the classroom as they can inside one.
We want kids to roll up their sleeves, dig in, to discover, play, and really learn without even knowing that they're learning. And I mean, that's what's really happened when you look here today. You watch all these amazing kids with their eyes, wide open. Many of them walk in with jitters. I mean, it's an amazing feeling knowing that we were able to pull this off and inspire many of these kids.
2, 1.
Every day, the world becomes a more technological place. And some of these kids are determined to be the ones inventing things that could have an impact on the future. College student Tori Griffiths plans to be an engineer and wants more of her female classmates to come along for the ride.
It's a common misconception is that only guys are engineers. And so by showing them here that there's a whole bunch of women here, there's a whole bunch of girls who are doing just as well as the guys are. There's a woman who is organizing this event. It's giving them the understanding that I am what an engineer looks like. I don't need to look like a nerdy guy behind a computer. Like, this is what an engineer looks like. We are engineers, and you can be one too.
While this event is designed to be fun, it's not all fun and games. High school student Tom Barnett is part of a team solving some serious problems.
One of the kids at my school was born without a hand, and so his mother came to our teacher, and we were pretty much just told, see what you can do and try and make him a hand.
The result? A working prosthetic hand, controlled by brain power, and developed by teenagers.
Your brain will send tiny electrical signals to your muscles, and those tiny signals will basically tell your muscles to clench. But we can also read those signals so that when your muscle is clenching, these sensors will basically read that, and then we can use those readings to control the hand.
Not bad for a group of high school students. And that's why the adults in the room, parents and teachers, are thrilled with events like this that foster their kids' love of technology.
The reason I brought my kids here is they definitely have an aptitude for the sciences, and this was a chance for them to really explore a little bit more. This is a chance for them to have a whole new world open up to them and explore some other different options that they might, be interested into.
I think it's a good idea for the children to get elbowed into it because it gives them a sense of, exposure and a sense of feel. Because I think learning offers a lot: seeing, feeling, smelling.
There are all sorts of new teaching tools coming online. This was a top hit at the Young Innovators Fair. It's called an Augmented Reality Sandbox. And while it seems like a toy, it's actually a sophisticated piece of technology.
At the Young Innovators Fair, crowds of kids and adults couldn't seem to get enough of this unusual piece of education tech.
I saw it and just thought, wow, that's the coolest thing ever. I could really use this in my classroom.
Coming up, I get hands-on with this sandbox of the future.
As a kid, I invested days at the beach, playing with water and sand, and really learning physics. This brings it into the digital age.
Welcome back to Earth 2050. Anyone who's watched this program knows a lot of things are changing, and fast. Food, transportation, medical tech, you name it, it's not like it was even a few years ago. The same is true with classrooms, as I recently found out at a high school in rural Pennsylvania. There, I caught up with some students at an earth science class that's nothing like I saw when I was in school.
Yeah, what is it about this that's better than a page in a book?
It's three-dimensional.
Yeah, it's three-dimensional.
Hands-on stuff.
Cool. Not really.
I mean, and I have to ask, a page in a book, if you're interested in it, can be exciting, but if you're not, I don't know. But is this more fun?
Yeah,
Definitely.
paper?
It's definitely more fun than reading.
This device takes learning to a new level by allowing students to interact with their classwork. Their teacher, Tom Lavanga, showed me how this high-tech sandbox is helping him teach science.
This is the kind of topographical map that I remember using.
Right. You would have your index contour lines written in there. To a young person first learning about topographic mapping, it just looks like a number of lines on a page.
This is so much more intuitively obvious. So how do the kids like this?
Without fail, the kids walk into the room. The first time they walked into the room and saw this, whoa, what is that? That's basically the first question you get. And that's, again, not just from kids, but from adults as well.
The concept is surprisingly simple. A 3D system captures the shape of the sand and then projects topographical images onto the surface of that sand. When you manipulate the sand, the topography changes, and it provides a pretty accurate simulation of what would happen in nature.
It's literally a sandbox. You got a box of what looks like very, very white sand.
Mm-hmm.
And if I do this, you can see it's just essentially white sand down there.
I can cover the projector here and just see we just have white sand.
And that's it, it's just like that. And then, so how does the system know how to map where the contour lines are? What is actually working up here?
So what drives the whole thing, the brains behind the whole thing is, besides the program, is an Xbox 360 camera, off-the-shelf technology. All this is off-the-shelf technology, which is the great thing about it, is that anybody that wants to make one can make one.
Want to see what happens after a volcano erupts? With this device, I was able to create a simulation of how a lava flow would affect the surrounding countryside.
These people are in trouble. So I'm not even going to touch the edge. I'm just going to pull a slump away down here. If it gets low enough, I would imagine, can it go out on its own?
Eventually, yeah, if we reach the top there just a bit.
Once the rim, or the caldera of the volcano is breached, hot lava means a lot of trouble for people living in the area. Take a storm surge, a very real problem for urban planners. If kids, or kids like me, want to see how something like a surge could affect a coastal city, we can do it thanks to this high-tech teaching tool.
We actually simulate a wave coming inland.
Gotcha. Oh, that's bad news for the
And
sound.
then so we have our barrier island being inundated, and the resort towns, the casinos.
Yeah, they're all gone. I mean, the highway is all cut off now.
They're all in the water, right? And now the barrier island is completely separated from the mainland.
So it's easy to see why the Sandbox was such a big hit at the Young Innovators Fair. The kids at the event loved it. If you're trying to get them interested in science, this is one piece of tech that's definitely up to the task.
It's been really cool knowing that a lot of people are coming to our to the sand table and they're seeing all the different stuff that can happen with just moving the sand around.
New hands-on tools are being developed every day to give 3D access to whatever it is we want to model, whether it's terrain or landscapes, asteroids, or the insides of cells. This makes it easy not only for people to program stuff so that kids can understand what's going on, but it makes it possible for the students themselves to decide what to model and how to model it. Coming up, students make history with 3D printing.
It's an opportunity to think through a lot of problems that you wouldn't ordinarily think through.
Good teachers are always looking for exciting ways to inspire their students, and new tech is giving them more options than ever before. Take 3D printing. It's been used by doctors, engineers, artists, even astronauts, and now it's being used in classrooms. History professor Susanna Lee recently gave me a tour of a 3D printing facility, what's known as a maker's space at North Carolina State University.
What can you do with a makerspace that you can't do in a regular classroom?
Well, I think the wonderful thing about a space like the makerspace is that it enables students to really engage their creativity. So a lot of the skills that we're working on with students, for a long time we really focused on critical thinking skills. And so now we're trying to incorporate both critical thinking skills and creativity.
This is happening all over the world, all the way from grade school through college. As 3D printing tech gets cheaper and more available, teachers and students alike are realizing that actually making things that relate to their coursework is an ideal way for people to learn.
Having the 3D printer in the classroom has greatly increased the creativity of the students. Many students who before, when given an assignment, would do the bare minimum are now really paying attention to the details so that when they get to print it out, they can see their hard work having a physical realization.
3D printing tech has all sorts of advantages. Not only does it let students dig in and make stuff, it allows them to interact with history in ways that books and pictures just can't do. Take these baby shoes, handmade in leather by an enslaved African American more than a century ago. They're delicate and need to be protected. If they get handled too much, they'll get damaged. So why not make a copy with a 3D printer?
Can you tell me why this makerspace is valuable to the study of those shoes for students?
Well, what we're trying to do at the museum is come up with a way for students. It's much more interesting if you can touch the things. And at the museum, most things are going to be behind glass, or in our cases where you can't really get the feel and understand what they were like.
So an artifact like this ancient arrowhead can be recreated exactly like the original. It's measured, scanned, and recreated on a computer before being sent to the printer. A few hours later, students have a copy in their hands, and museums can have an exact replica that they can reproduce as often as they like.
Things do degrade over time. It's happening naturally, you know, and so our job is to try to protect things as best we can. But, you know, eventually time's going to win. So one thing we like about this is it does perform some documentation.
Of course, there's nothing like the originals, but these 3D facsimiles are providing options for both museum curators and especially students that didn't exist as recently as a decade ago.
Can you learn things by making something that you wouldn't learn the normal way?
I think so, because it's an opportunity to think through a lot of problems that you wouldn't ordinarily think through or that you wouldn't really encounter. Students are very accustomed to writing papers, but it's harder to build something from scratch. It's an unfamiliar experience.
Major museums from Boston to Beijing are turning to 3D printing to reproduce their entire collections. In the past, they used photographs to do this, but no matter how good the picture, it's still two-dimensional and flat. By 2050, a lot of the world's historical artifacts will have three-dimensional replicas that could be printed with the press of a button.
It's a way of sharing our cultural history with people who may not ever be able to visit a museum halfway around the world, but they could print something at home and have a replica of what they're not able to even go and see in person, but something different than just looking at an image of it.
So by 2050, we'll be able to 3D scan and print something in color with full function in seconds. We might not go to the store for a piece of hardware. The store might be a corner of our house where we just download whatever we want and print it. So by 2050, what is 3D printing going to be like? We won't even call it that. We'll 3D scan and print in full color with full function without even thinking about it. Coming up, sports get off the athletic field and into the classroom.
I like that it's a team atmosphere and it's a lot about creativity, and there's a lot of different ways that you could go with it.
Welcome back to Earth 2050. When Mother Nature dumps a few feet of snow on some major cities, it creates a whole host of problems for government officials. Digging out takes time, heavy equipment, and a lot of money. But for these high school students, a blizzard presents a different kind of problem, a math problem with all sorts of potential answers.
We're trying to figure out how much money should be allotted to each city in order to manage the amount of snowfall they experience annually.
Why are they trying to come up with solutions for a tough problem like managing urban snowfall? Because traditional sports aren't the only place where high school students like to compete. Welcome to Moody's Mega Math Challenge, or the M3.
M3 Challenge is a high school math competition for juniors and seniors, and it's really neat because it's an opportunity for these students to bring forward what they're learning in the classroom in their calculus classes and algebra classes and actually apply it to a real-life problem.
Yes, this is about using math to solve problems, but the other key word here is applied. This is a lot more than a typical academic exercise.
Using our mathematics skills to apply to our daily problems, like the snow moving, this is very like a daily problem, right? So we are using our math talent or math skills to really help the society and governance. So that's really cool, I think.
The Society of Industrial and Applied Mathematics, which organizes the M3, thinks it's pretty cool too. They're all about making sure today's students in the US can compete with their counterparts around the world.
We pretty much exist to create cooperation between applied math and the fields of science and technology.
Teachers and students say a math challenge like the M3 is where math education needs to go as we approach the year 2050.
It could be the future of learning because you would use this in real life compared to learning about the Pythagorean theorem. I mean, you could use this for figuring out tons of things like budgets, especially like what we're doing now for like a multitude of things.
Applied math is definitely a future of education because the curriculum that we are currently working on was designed many years ago. A lot of things have changed.
One of those things is access to more information than the parents of these kids could only dream about. Grab a computer and all sorts of data, usable data, is at their fingertips in seconds.
We had Excel sheets for years from I believe 1862 to 2016. So we did have a lot of information to start off with.
10 or 20 years ago, it might take days to get that kind of information. So these kids have a lot of data to work with, but not much time. For this qualifying round, they have 3 hours. For the national competition, which involves nearly 5,000 students, they have 14 hours to come up with a solution to a completely different problem.
I think students learn the most by using what they learn in the classroom and apply in a real-life situation.
The top 6 teams travel to New York City, where judges award more than $150,000 in scholarships. The money is provided by the Moody's Foundation, the philanthropic arm of the Moody's Corporation. As for the students, using teams to create solutions and having fun doing it is great preparation for future careers in math and science. Welcome back to Earth 2050. If you haven't personally seen some of the tech we showed you today, well, you will. Why? Because educational tech is getting cheaper and more available every day.
Particularly in the Earth and Space Science classes, this will be really useful for teaching more difficult concepts like topography, contour mapping, and things like that. I think something like this, it's interesting, it's fun to play with, but when you start to look, as maybe an 11, 12, 13-year-old kid who might be interested in programming and things like that, start to look at the construction of the whole box itself, and really it's more than just a geoscience project. It could be a computer science project. There's art applications that you could take with this, modeling 3D form.
How do you see the teaching of history changing in the face of this kind of technology by 2050?
Well, one of the things we really struggle with as history educators is to really engage students in the past, which seems so different, so distant, and so unimportant to us today. And so one of the, I think, promising aspects of 3D printing is that potentially it can help us engage students in the future. So I think history education will really be able to take advantage of technologies like 3D printing to allow people to really engage with the past in more tangible ways.
Well before 2050, school will be totally transformed over and over and over. Each new piece of tech expands the possibilities for how we teach each other. That's it for this week's edition of Earth 2050. I'm Chuck Pell. I'll see you next time.